Hello everyone, welcome to Insight Engine Academy. So we are going to discuss first chapter rational numbers from 8th standard mathematics. So in which in the previous classes we have discussed about properties of rational numbers, and in the second exercise we have discussed how to represent rational numbers on the number line. So now come to the exercise 1.3. So before going to discuss the problems from 1.3, let us discuss how these rational numbers can be converted into terminating and non-terminating decimals. So how many types of decimals are there? Let us write. If you consider set of rationals, so set of rationals can be converted into two types of decimals. That is, one is terminating decimal, the other one is non-terminating recurring decimals. As you know that rational numbers by q, which are generally in the form of p by q, right? So these numbers p by q, when you divide, you will get certain values, quotient values. That when you divide it, some of the numbers will become terminating. For example, 1 by 4 if you consider, which is equal to 0.25. After the decimal point there is a fixed number of digits. If there exists a fixed number of digits and it ends with a certain number of digits, then it is called what? Terminating decimal. And if you consider 1 by 3, which is equal to 0.333 and so on, when you divide 1 with 3, we will get the decimal value as quotient value as 0.33 so on, which can be written as 0.3 bar. The digit which is repeating can be written as what? 0.3 bar. Here in this case, this decimal is non-terminating but recurring. Okay. So any rational number comes under these two categories. Either they terminates, otherwise they are non-terminating but recurring decimal. Now in this exercise 1.3, we are going to discuss any p by q form of rational numbers will be converted into terminating or non-terminating. If they given non-terminating decimals, we can convert into p by q format, right? Otherwise, if the terminating decimals given, we can convert into p by q format. Let us discuss the sums from the exercise 1.3. First bit, express each of the following decimal in what format? P by q form. So that what is the first question given here? 0.57. After the decimal point, how many digits are there? 2 digits. So we can write this as 57 by, if any term is not there, we can take its quotient as 1 or divisor as 1. 1 after, how many digits are there here? 2 digits. So that we can write 2 zeros, that it becomes 57 by 100. So given decimal converted in the form of what? P by q. In the same manner, next question, that is 0.176. So it can be written as 176 by, after the decimal point, how many digits are exist here? 1, 2, 3. So that we can write 1000. Next, 1.00001. After the decimal point, how many digits exist? Count that. 1, 2, 3, 4, 5. Therefore, 1 after we can write 5 zeros. Right? Now, here also 25.125. It can be written as 25,125 by 1000. Right? So here it is 1 lakh by 1 lakh, 1 by 1 lakh. It is 25,125 by 1000. So these are the expressions of each of the decimals in the form of p by q. Among these, which term is able to cancel by any common factor? Let us check. 57 by 100, it cannot be. So that next one you can check it here. It can be cancelled by 2 8s are 16, 2 8s are 16, 2 500s, next 2 44s, next 2 250s, 2 22, 2 125. So that it becomes what? 22 by 125. It cannot be cancelled. Here we can check it. 5 5s are 25, 5 2s are 10, 5 5s are 25, 5 2s are 5 zeros. Next, it becomes what? 525 by 200. So what does it become then? 5 1s are 5, 5 zeros are 0, 5 5s are 25, 5 4s are 20, 5 zeros. Next, it becomes 105 by 40, 5 2s are 5 1s are 5 8s are 40, 21 by 8. So where there is a chance to convert into simplest form, we can convert into simplest and we can write it as a p by q. What is the question? Let us observe that. Express each of the following decimals in the rational form, that is p by q form. What is the decimal given here? 0.9 bar. That is, let x is equal to 0.9 bar. So it will become what? 0.999 and so on. As bar for the single digit 9, so 9 to be repeated a number of times as it is recurring digit. So now, what is the periodicity here? Periodicity in the sense, the digit, the number of digits which are recurring is called periodicity. Here, the periodicity is 1. Let it be equation number 1. So, we have to multiply equation 1 with only periodicity 1, no, so that we should multiply with 10 on both sides. Right? So that what does it become here? It becomes 10x, which is equal to, when you multiply with 10, decimal point moves towards right side, then what has become? 9.999 and so on. Let it be equation number 2. Now what is the first equation we got? X is equal to 0.999 and so on. That is equation number 1. So let us subtract equation 1 from 2. So 10 times of x minus this is 1 time of x. So what does it become here? 9 times of x, which is equal to, these recurring digits gets cancelled, then 9 minus 0 is 9, right? Therefore x is equal to 9 by 9, which is equal to 1. That means, what is the final conclusion? What is x actually? 0.9 bar. That means 0.9 bar, which is equal to 1 when you written in the form of p by q. See that method 2. Here 0.9 bar, so which is equal to, what are the digits total we have here? That is 0, 9 you should write, and number of recurring digits here. What are the digits recurring? How many digits are recurring? Only 1 digit. So that in the denominator we should consider 9. 1 times of 9. 9 ones are 9 ones are, which is equal to 1. Nothing but the result is 1 for this recurring decimal. When you written in the p by q form, you will get as 1. It is a shortcut. First we need to write all the digits which are in the exist in the given decimal in the numerator, then divide by the number of recurring decimals. How many recurring decimals are there? Those many times of nines to be considered and cancel them. Whatever the result you got, that is a required p by q form of the given decimal. Here the second question from this bit is 0.57 bar. So how to find the solution? Let us see here. Let the given decimal as x first of all. X is equal to 0.57 bar. When you remove this decimal bar from the decimal point, then what you get? 0.57, 57, 57 and so on. So let it be equation number 1. Now if you observe here, what are the number of digits repeating in this? 2. Therefore the periodicity is here what? Periodicity 2, right? Periodicity is nothing but what? Number of digits which are recurring. How many digits are recurring here? 2 digits. Therefore the periodicity is 2. So multiply equation 1 with 10 power 2. That is periodicity 2. So that 10 power 2. 10 power 2 is nothing but what? 100 on both sides. Right? On both sides when you multiply, what you get? Let us see here. 100 into x, it becomes what? 100x. Then when you multiply with 100, decimal point moves towards right side by 2 digits, that is 57.5757, you'll get it. That is equation number 2. Now what is equation 1? 0.575757, which are recurring. That is equation number 1, right? Now let us subtract equation 1 from 2. Then what you are going to get? If any coefficient is not there, we can consider it as what? 1. 100 times of x minus 1 time of x, it gives us 99 times of x, right? Which is equal to, let us cancel the recurring digits, 57, 57, 57. Now what left over here? 57 minus 0, that is nothing but 57. So then x is equal to 57 by this into 99. If you transpose, it becomes 57 by 99. But what is x actually? What is x actually? X is nothing but 0.57 bar. That is 0.57 bar, which is equal to 57 by 99. Right? This is the answer. So for this, if you observe the second method, very simple. How to write part B? In a fraction of seconds, we can conclude this. 0.57, which is equal to, what are the non-recurring decimals? That is 0 plus recurring decimals. What are they? 57 by number of recurring. For every recurring digit, we should write 9. 5, as 5 is recurring, we should write 9 once. As 7 is recurring, we should write 9 once again. So that what does it become? 57 by 99. So we got it the conclusion as we got in the previous. Also simplify in both the cases, that is with 3 table it can be cancelled. 3 ones are 3 nines. Next show 3 threes are 3 threes are. So that 19 by 33 got it. In the same manner here also 19 by 33. Whenever it is get in P by Q, we can convert them into simplest form. Let us see the next question, that is 0.72 bar 729 bar for only for 2 digits, that is 29. So here non-repeating decimal value is there and at the same time repeating decimals also are there. So in this case we have to follow this rule. So first let x is equal to 0.729 bar. That implies x is equal to, what can write here? 0.7. 7 is non-repeating term, non-repeating decimal, but 29 is what? Repeating decimals. So and so on. Let it be equation number 1. Now observe that what is the periodicity here? 2. But after the decimal point, how many digits are there? Total 3. Here number of decimals is 3. So multiply by 10 power 3, which is equal to 1000 on both sides. That is one case. What you get? Let us check it here. When you multiply with 1000, 1000x is equal to, decimal point moves to 3 digits as number of decimal values, decimal digits is 3. So 100x is equal to 1000x is, which is equal to what you get? 729.292929 so on. Let it be equation number 2. Now number of recurring digits are 2, so that periodicity is 2. So we have to multiply by 10 power 2, that is nothing but 100 on both sides. What you get? Then check it. 100x is equal to, see that 100 into x, 100x, which is equal to, when decimal point moves here, number of digits which are repeating is 2 digits, that is 2929. Therefore the periodicity is 2. So multiply by 100 on both sides. That is, what do you get? 100 times of x, which is equal to, when you multiply with 100, decimal point moves towards 2 digits, that is 72.92929 so on. So equation number 2. What is the first equation? X is equal to 0.72929 and so on. It is equation number 1. Let us subtract. Here what is the quotient of x? 1. 100 times of x minus 1 time of x gives us 99 times of x. 29 gets cancelled. 9 minus 7, that is 2. Now here 72 minus 0 is 72. So then x is equal to 72.2 by 99, right? When you remove this decimal point, what you get? So which is equal to 722 by 990. We can cancel it with a common factor 2. 2 3s are 6, 2 6s are 12, 2 1s are 2, 2 4s are 8, 2 9s are 18, 2 5s are 10. So then what you get? 361 by 495. Therefore 0.729 can be written as 0.729 bar can be written as 361 by 495. See that? First write the number, that is 0.729 bar, which is equal to, here write total digits, that is 729 minus what are the non-recurring digits are there here, that is 7, by number of recurring decimals, that is 2 digits are there, so that we should write 2 nines, and non-recurring digits, for that 1 0. For recurrings we should write 2 nines, for non-recurring we should write what? 0. Then what you are getting? Check it. 722 by 990. If you cancel with a common factor, 2 3s are 6, 2 6 are 12, 2 1s are 2, 2 4s are 8, 2 9s are 18, 2 5s are 10. Therefore 361 by 495. Got in the earlier, the same result will come. When it comes in the part B, we can write in this manner. Very simple. Once again remind, write entire digits here. Okay. Then subtract the non-repeating decimals. That is 0.7 is there, 7 to be subtracted from the numerator. In the denominator, we should write recurring. How many digits are recurring? Those many number of times of 9. Then how many non-recurring digits are there? Those many number of zeros. So by that, by simplifying this, you will get as required rational form of the given decimal. Yeah, let us solve the fourth question from this bit. 12.28 bar for only the single digit 8 here. So as you know that, what is the general procedure? Let us assume x is equal to 12.28 bar. Right? This decimal is certain rational number. What is the value of this x value? You need to find it. So now, what is the digit repeating in this case? So that can be written as 12.28 and so on. It is equation number 1. 8 is the recurring decimal. Now, what is the periodicity here? Here, the periodicity is 1. So, we have to multiply equation 1 by 10 on both sides, right? So that what does it become? 10 into x, 10x, which becomes decimal point moves towards right side 1 digit, then 122.888 and so on. It is equation number 2. Then what is the first equation? X is equal to 12.2888 and so on. It is equation number 1. Let us subtract. When you are subtracting, 10 times of x minus this 1 time of x gives us 9 times of x, which is equal to 8 minus 8 gets cancelled. So here 8 minus 2 is 6, 2 minus 2 is 0, decimal point same as consider. So 2 minus 1 is 1 and here it is 1. So 110.6 by, which is equal to what? 9x. So then x is equal to 110.6 into 9. If you transpose, it goes to denominator. What does it become then? 110.6 by 9. If you remove the decimal point here, you'll get one more 0 in the denominator. Then let us cancel it and write into simplest form. So as in the ones place, there is a 6 and 0. Both are even, so that we can divide by 2. So 2 5s are 10. Next 2 5s are 10. 2 3s are 6. Right? Next 2 4s are 8. 2 5s are 10. As this gets cancelled, 553 by 45. Okay, now let us check it by the second method. In the second method, let us consider the given decimal, that is 12.28 bar, which is equal. First, let us write all the digits in the numerator, that is 1, 2, 2, 8. From this, we need to subtract the non-recurring decimals, that is minus 1, 2, 2. So, which are non-recurring digits by. Now number of recurring, how many are there? 1 digit, therefore we should write only 9, 1 times of 9. Next, number of non-recurring decimal is only 1 digit, so that we should write a 0. What you are going to get it, check it now. 8 minus 2 is 6, minus 2 is 0, 2 2 minus 1 is 1, then 1. 1106 by 9. Let us cancel by common factor 2. 2 5s are 10, 2 5s are 10, 2 3s are 6, 2 4s are 8, 2 5s are 10, that is 90. So then what you get? 553 by 45. See that in both the cases we got the same results. So it is a method to be followed in board exams, whereas it is to be followed in part B.